All right, we're going to go on to the last chapter or section of this chapter, which is 7.2, which is estimating population mean or mu. Okay. So instead of using proportions and percentages and decimals, we're actually going to be using the average mean to figure out the average to the population mean. So again, we're going to go through the key concepts again and then kind of go through more of the definitions. So the main goal is to represent methods for using a sample mean or X bar to make inferences about the corresponding population mean or mu. There are three main concepts to this. So essentially what this is like, instead of me asking what percentage of people have an Instagram, now I want to know on average how many minutes does each person that already uses Instagram or on Instagram. Okay, so I'm trying to find the average this time. And so what if I average was 30 minutes a day? Well, can I make that same thing saying the population is 30 minutes a day? So essentially what we're doing is we're not looking at a percentage anymore, we're looking at an average. So the point estimate, and I should have done fill in the blanks, but essentially, and it's the same thing, the sample mean, so instead of the sample proportion, we're using the sample mean, which is X bar, okay, is the best point estimate and I got this from your book too, so you can just copy it from your book if you want to. It's the best point estimate of the population mean, mu. Okay, confidence interval. Okay, so what we're gonna do is we're going to go ahead and sample data. Okay, so we're gonna sample data to construct and interpret a confidence interval. And if you remember confidence interval, I'm going to rewrite a CI for the true value. And instead of writing proportion, we're not looking at proportion anymore. We're going to say the true value of a population mean. So it's not the population proportion anymore, it's the population mean or mu. Okay, and the last thing is the sample size, which essentially is, again, the same thing as before. We're going to use the lowercase n, but it's going to be, we're going to have to use a formula, but we're going to say find the sample size. Sometimes I will ask this. So find the sample size necessary to estimate the approximate mean. Okay, so some notations. And this one, we're going to have you go ahead and I want you guys to make a little note. We don't know what sigma is. There's a don't know sigma and there is a do know sigma. So this breaks off into two ways. So this one is we don't know sigma. Okay, so some notations we need. What does mu stand for? Well, again, mu is the population, which I'm going to write population mean. And what is that? The difference between X bar? X bar is the sample mean. Okay, what is S? Remember, S is the standard deviation of samples, or sample standard deviation. And what is sigma? That is your standard deviation of population. Okay, some other numbers you need, or variables you need, is N, which is the number of people or samples. So I'm going to write number of samples, which is the number of people. E is the margin of error. So that's the same as the last section. And then the last one you need, I'm going to write it in a different color, is called DF, which is going to stand for the degrees of freedom. Okay, and the formula to this, and yes, it's a formula, it's just n minus 1. It's how many people you're looking at minus 1. Okay, now your requirements. Now it's not 6 of them like the last section. The requirements, there's only 2 of them, but one of them's tricky, and we're actually going to have practice with that a lot. But the first requirement is it an SRS? Is it a simple random sample, or does it say randomly sampled or randomly selected? That's the first check. The second check, it actually breaks down into 3. And if you remember from the last section, we already talked about that. So remember, the first one says, does it say normally distributed? If it does, we're done. So normally distributed, if it says it, we're done. The second one, I'm going to write B. The second one is if n is greater or equal to 30. And this was section 6.4, so we're going to say if n is greater or equal to 30 by CLT, or central limits theorem, it is approximately normal. So by CLT, it's approximately normal. And what happens if it's neither of those? Well, we're gonna see two of those examples in this in these notes, and that's why I wanted to do these notes a little bit more thoroughly. Is if it's neither of those, you actually have to draw a box plot, which is really good example because you're gonna be asked to do this. You're gonna be drawing a box plot and state. You're gonna state this: no strong skewness, and I say strong because sometimes it could be skewed, but it's not strong. No strong skewness or outliers. So approximately normal. And that's literally what we have to do. You have to draw out the box plot and then you have to actually write this out. Okay. Your margin of error. It is a formula. Let's go ahead and write it here. So it's going to be E equals, and instead of Z, since we don't know what sigma is, it's not 0 or 1 in your standard normal curve, we're going to say it's T. And we're going to talk about a t-test, not a z-test, and this is going to be alpha over 2. So it's kind of just the same thing as the last section, except this time we're using t and not z. And then this time we're not multiplying it by p, by the square root of p hat and q hat, because we don't have these proportions. Instead, we're going to do the sample standard deviation over the square root of n. And if you think about it, we did this the last chapter as well. We did s over the square root of n when we did binomial. Okay, what's your confidence interval? Again, there's two ways to write this. It's just x bar plus or minus your margin of error, which if you want to write this is x bar minus e. So you can write it like this, or x bar plus e. And then you want to write sentence. I'm going to write sentence. And again, I give you another sentence frame. It's very similar to the last one, except I changed like 3 words. And those are the 2 sentence frames you need to know for this. And then you write sentence, and then the round off rule. Again, same round off rule as before. Write 3 decimal places, or a whole number if solving for n. Okay, so only when you're solving for n, you round to a whole number. Otherwise, it's 3 decimal places, ideally. Okay, so what is a t-distribution? Well, a t-distribution is that sigma is unknown. We don't know the standard deviation of the population, so we use t. I don't know why it's z and t, but that's what it is. And the formula for it, again, if you wanted to do this by hand, is x bar minus mu over s over the square root of n. Now, I'm going to use my calculator a lot more. I'm not actually going to use this formula. And then the degrees of freedom, I already talked about it, is this, the acronym is df, and it's n minus 1. And how do you find your critical value of t alpha over 2? Well, it's not like the ones before. It's not just the chart. Again, you can make a chart using your t values, but you're going to use technology again. But you're not going to use inverse norm anymore. You're going to use inverse t. So how do you do that? Again, you write second, and we're going to do an example of this. So second, vars. And instead of using 3, we're going to use 4, which is the inverse t. Okay, and then you're going to type in everything else. So you're going to need your degrees of freedom, and you're going to need your area. Okay, and those are the only 3-4 steps that you need for this. Okay, so let's go ahead and I'm going to write out the steps, and then we're going to go ahead and do a couple of examples. And that's pretty much all the notes to this, is like a couple steps and a lot of examples, which is a good thing, right? Because it's notes. So there are 4 steps to this. So the first step is to check requirements. Easy. Cool. The second step is you want to calculate, well, we're going to write with sigma unknown. Okay, so with sigma unknown, use df of n minus 1 and inverse t. So we're going to use the inverse t if we don't know what, so essentially what we want to do is you want to find t of alpha over 2. Okay, that's the second step. The third step is to calculate the margin of error. So we're going to calculate E. And if you don't remember the formula, we wrote it on the previous page, but it's T of alpha over 2 times S over the square root of N. Okay, so that's the margin of error. Again, I didn't write margin of error, I just wrote E. And the fourth step, okay, is to find your confidence interval, which again, you're going to write with sentence. And that formula is X bar plus or minus your margin of error. And you're going to write it in parentheses, like both plus and minus. Okay, and again, rounding rule happens, but this is essentially the 4 steps that you need. So let's go ahead and try an example. So this one says, find the critical value of t of alpha over 2, corresponding to a 95% confidence level, given that the sample size is n equals 15. So let's go ahead and write like a little image first. So we're going to go ahead and draw a normal curve. Again, it's a normal curve still. The inside part is 95%, so 0.95. So it's essentially the same as before. So what's left over? Well, if 0.95%, that means your alpha is 0.05. Remember that these two numbers add up to 100. So what goes in each of these charts? Well, in each of these is half of alpha, which is 0.025. And you're like, this is exactly like the example before. Yes, but we're looking for a t value, not a z value, because we don't know what sigma is. Okay, and so your area is still the same, but we're going to use the degrees of freedom. Now remember, degrees of freedom is n minus 1, so that's 15 minus 1, which is 14. And so again, we're going to go ahead and find it. So we're going to write inverse t, and again, if you're using the calculator, all you have to do is you just have to do the picture and the drawing and then write a sentence. Remember if we from the last section. So you do second vars, you're going to go to inverse t, so it's number 4. The area, again, I'm going to do this side, but remember it's always the positive number that we get to, but it's going to be 0.025. But notice it asks you degree of freedom, so we're going to say 14. And we're going to take the positive. So I'm going to write this information down. So I'm going to write 0.025 and 14. I'm going to label it. So this is going to be area in degrees of freedom. And I'm going to take the positive of it. So I'm going to say this is 2.145. And remember, 3 decimal places is ideal. And that is your t value. Okay, so you're going to say our t value, or z, like it's a z-score, our t value is 2.145. Something really simple, like boom, done. Okay, all right, so let's go ahead and do an actual example that does all 4 steps. And I'm actually going to be a little evil and talk about the requirements in terms of what happens if it doesn't fall into the 2 categories. So you'll see. So it says, listed below are the weights of randomly selected girls at birth based on a data from the National Center of Health Statistics. Here are the summary stats. So it actually gave me some information. It told me n was 15. That means that there are 15 numbers. Your mean is 30.9. And notice it's X bar, not your mean. And your S is 2.9. And this is very key, and I want you guys to like realize this. I gave you your S value. I didn't give you your mean value or your population standard deviation. I gave you sample standard deviation. Use the sample data to construct a 95% confidence interval for birth mean weights of girls. So notice it doesn't ask you for a sentence, but every time you find a confidence interval, you have to write a sentence. So let's go ahead and do step 1, which is check requirements. So first step is check requirements. The first part of the check requirements, is this a randomly selected, or does it say SRS? And it says randomly selected. So I'm going to say randomly selected. That's all I have to do. Part B. Now, n is not greater than or equal to 30. It does not say normally distributed. So guess what? We're going to have to draw a graph. Okay. Again, this part is just like the notes, but you don't have to write all this. I'm going to say since n is less than 30 and doesn't say normally distributed, we have to draw a graph. We draw a graph. Again, these are notes. That's why you don't have to write this part. You just have to do it. Okay. So let's go ahead and draw a graph. So I'm going to kind of go through this quickly. I'm not going to go through every single step because, well, you should know how to draw a box plot on this. So the first thing you want to do is you want to enter these data into a list. And so how do you do that is you go to Stat and you go to Edit. And you have your list. Now, I already typed it in, but I created a second list to show you guys how to clear it. So remember, like, you can't just hit clear. What you're going to do is you're going to go highlight pretend you wanted to delete these numbers and type more in. So what you're going to do is you're going to highlight the list you want to delete and you hit clear and enter. Okay. And again, you can always YouTube how to draw a box plot on a TI-84. Like you could do that if you wanted to, and it'll tell you how to do it. But I already entered everything in. So you're going to go ahead and enter in the 15 numbers. Okay, I already did it, so I'm not going to do it. And then the next thing you're going to do is you're going to quit. So how you quit is you hit second mode. And we're going to go ahead and draw in the stats. So we go to second, y equals, which is second stat plot. And you're going to go to the first one, and you're going to, if it's flashing off, you're going to turn it on. And you're going to go ahead and go to the one that is a box plot with the outliers, because you want to say there's no outliers. And then you're going to go to X list. Now we want this to be L1 because that's where I typed in the information. So I'm going to go to second 1. Frequency is going to stay 1. The color mark doesn't matter. The color doesn't really matter to me. So the last step is you want to graph it. So how do you graph it? Well, you hit zoom and you go to 9. Okay, and we're going to just sketch this. We're not going to actually graph it. If I were to graph it, I would actually have to write out the values, but I'm just going to go ahead and sketch that. So this is what I would actually write. And what I'm writing is in blue is what you would actually write. Okay, so again, I get, I'm just going to draw this out. So something not exact, okay, but I just sketched it. I didn't really do this. And I'm going to actually have to write no strong skewness. It's skewed a little bit, but not too much. Like, yeah, there's this a little bit skewness, but it's not strong. I mean, it's like switch to one side or switch to the other. So no strong skewness or outliers. And you would tell outliers because there would be points on the outside of them. Okay, so it's approximately normal. Again, whatever I'm writing in blue is what you would write as your answer. Okay, you don't have to write out the black part. You just have to write the blue part out. Okay. So that's literally step 1, and that was a lot of work. Step 2, with sigma unknown, use degrees of freedom and inverse t to find t of alpha over 2. So step 2, which I should write out in blue because I told you guys I'll be doing this in blue. 95% confidence. Guess what? We already did it. So I'm going to say t of alpha over 2 is 2.145. And yes, you don't really have, unless I'm asking for it by hand, you don't actually have to calculate it. You can just go ahead and just write it out. Unless it's a question where I ask you to find it, I want your work. Otherwise, you can just write it out if you're just asked to find like a confidence interval. Okay, step 3, calculate your margin of error. So E equals, I'm gonna write out the formula. Again, you don't have to write out the formula. It's just to help, like, because there are so many formulas to this. So we're gonna do 2.145 times, and then your S, which is 2.9, over your square root of n, which is 15. And I'm going to go ahead and use my calculator. So I'm going to quit this. So to quit is second mode. I'm going to do 2.145 times 2.9 divided by the square root of 15. And I'm going to get, and round to 3 decimal places, 1.606. And that is my margin of error. My 4th step is to find the confidence interval with a sentence. So remember, it's x bar plus or minus your E. So what is your x bar? Well, you calculated it, or it told it to you, as 30.9 plus or minus 1.606. So I'm going to do 30.9 minus 1.606 first. And I'm going to go ahead and write out 29.294, and then I'm going to change it to addition. I'm going to get 32.506. Okay, now the second part says write a sentence, and I realized the sentence is on the next page. It's literally the top of the next page. I ran out of space, so this is the next page. Again, I'm going to have you guys highlight it. It's the same one, except this one's dealing with mean, whereas the one before was dealing with population. So I'm going to use it and go ahead and write it out, and you're going to see it's very similar to what the other one is. So it says we are 95% confident that the interval from, and I'm just copying the sentence, 29.294 to 32.506 contains the true value of mu. And that's really, the ending just changed. Everything else was the same. Okay, so that is the end of the problem. We we checked. So if you remember from the first day of class or second day of class, this was the state, the plan, the do, conclude. Like, that's essentially what it is. It's the 4-step process, and we're going to be using these a lot. It's going to be the same thing over and over again, okay? So let's go ahead and go on to another example. Oh, so here's your sentence frame. So again, if you want to memorize this or highlight it, things that are important, this is your sentence frame for section 7.2. And there's only 2 sentences for this. I think there's only 2 more sentences after this for the entire rest of the book. Okay, so there's 4 sentence frames total of this entire second half of stats. Okay, so let's go on to the next page. And so the next page asks you to, samples of DNA are collected and 4 DNA, oh, so I forgot the word random samples. I forgot, this question came out a little bad because I copied it. And the 4 DNA sample bases A, G, C, and T are coded as 1, 2, 3, and 4 respectively. Okay, so they changed something categorical and changed it to quantitative. That's allowed if it tells you what they are. So it says the results are listed below. Haha, forgot that part. Construct a 95% confidence interval estimate for the mean. Okay, so I'm actually going to do this calculation by hand or by calculator and show you what that is. So notice it doesn't ask you for your margin of error, so I'm not going to solve it. I'm just going to find the 95% confidence interval. Now, I didn't give you the numbers, so I'm going to have you guys go ahead and copy this down, and usually I give it to you. So it's 2, 2, 1, 4, and then 3, 3, 3, 3. Like, this part is given to you. It says they're listed below, and I forgot to list them below, so I'm sorry. Okay, so let's go ahead and do this. And again, I'm going to show you guys on the calculator how to shorten up some of it. Not all of it's going to get shortened. So the first step is, does it say randomly sample or random samples? Yes, it does. Again, I forgot the word random, but it's there. So random samples of DNA are collected, and then the second, remember the second criteria is n has to be greater than or equal to 30, which n is 1, 2, 3, 4, 5, 6, 7, 8, so it's not. And it doesn't say normally distributed, so we have to graph it. Okay, so we're gonna go ahead and graph it on our calculator. So if you wanna pause it and try it out yourself, you can. If not, well, I have to type this out for this one, so I'm gonna hit, what I did was I hit stat, edit, and I have to clear out my first list. So to clear it out, I highlight it and hit clear and enter. I'm gonna hit 2, 2, 1, 4, 3, 3, 3, 3. I'm gonna go to second y equals. I'm gonna turn on the first one. Just make sure everything's right. It should be the same settings if you didn't do anything with it. I'm gonna hit zoom 9. Now this one again, notice that's not a box plot. That just means your Q1 and either Q2 is the same here or it's the same as Q3. So I'm gonna go ahead and I'm gonna draw this out. So I'm gonna say, and it's not skewed at all. It's actually symmetrical. So I drew it out, and then what are the words that we use? We're gonna say no strong skewness or outliers, so approximately normal. Okay, now here's where it gets a little cool. Okay, the second step is actually to find your T alpha over 2 and then calculate your margin of error and then your confidence interval. You don't have to do any of that if you're using your calculator. Okay, so instead what you have to do is you have to know some information. So the first thing you have to do is you need to know what test to do. And so you're gonna go to stat, and then you're gonna go to test. And then instead of using 1 prop z interval, we're gonna use T interval, because that's essentially what we're doing. And I'm writing 8 because it's 8 for me. It might not be 8 for you. Okay, so I'm gonna do that part. So you're gonna go to stat, tests, and you're gonna scroll down to number 8, which is a T interval. Okay, then we're gonna look at data or stats. Now here's the thing. We're gonna actually, there's a little shortcut. So instead of you typing in all the information it gives you, because that means you have to find the average, you would have to find your standard deviation of a sample. Instead, if you go to data, and it asks you, where is your data listed? So data means that it's in your data lists or it's in your list. Stats means you actually have to hand find them out. But we have everything in a data, but it's not in L2, it's actually in L1. So I'm gonna hit second L1. My frequency is gonna stay 1, and my confidence level is not 95 or 99, it's 0.95. I'm going to hit calculate. Okay, now what do I have to write in terms of like, okay, what did I do? So if you're using a calculator, okay, you have to actually write the test you're doing. So if you were to write this, you would write T interval. You would write what you wrote. You did stats. Oh, sorry, you did data. And I'm going to go to it just so you guys see it. So stats, number 8, you did data. You don't have to write L1. You have to write confidence level is 0.95. And guess what? It gives you your confidence, your interval. Okay, so I'm going to round to 3 decimal places, 1.859 and 3.391. Okay. My X bar is, and I'm going to write everything it gives me just in case. So 2.625, N is 8, and S sub X is 0.916. Okay, again, you don't have to write this black part out. You just have to write out this part. And then what's the last thing we have to do is I'm going to just write it. You're going to write a sentence. I'm not going to actually do it, but you would write, we are 95% confident that the interval from 1.8959 to 3.391 contains the true value mu. And that's the sentence. All right. Now, that's if we don't know sigma. What happens if we do know sigma? This is the last part of this chapter. Okay, so what happens if you know sigma? Well, if you know sigma, guess what? You're going to be using a z-test instead of a t-test. And that's what we did in the last chapter. So some notation. Again, the same notation as before. What is mu? That's your population mean. What's X bar? That's your sample mean. What's S? That's your sample standard deviation. And what is sigma? That is your population standard deviation. And I'm going through this quickly because you've seen these before. Okay. What is your E? That is your margin of error. And what is one thing you need? You need to know what your Z of alpha over 2 is, and that's your critical value, or if you want to call this is your Z score. Okay, so essentially we're going back to the same 7.1 notes, and that's if we know sigma. If we don't know sigma, we use a t-test. If we do know sigma, it's a z-test. Okay, so the requirements, it's actually the same thing. Does it say SRS or simple random sample or randomly selected? And the second step breaks off. So first one says normally distributed. Part B says that if n is greater or equal to 30 by CLT, it's approximately normal. And C is draw box plot. And I'm not going to write all the steps out, but it's like say the no strong skewness and no outliers. So it's approximately normal. So it's essentially the same steps as before. But the margin of error in your confidence interval change. So your margin of error is not T anymore. It's going to be Z of alpha over 2 times, and we had S over the square root of n, but since we know sigma, it's going to change to sigma over the square root of n. And that's essentially the only difference. You have your Z, alpha over 2, and you have your sigma. And your confidence interval, it's the same thing. So X plus or minus your E value. And you're going to then write sentence. And guess what? It's the same sentence as before. It's actually going to be this sentence. Okay, so same sentence for this section. So it's, again, you have to know if it's mean or if it's population proportion. All right, round off rule. Same rules. 3, 4, E, and confidence interval. And whole number for what? N. Okay, so it's pretty much 3 for everything other than n. Okay, so let's go ahead and do, again, an example. So it says use the same 15 birth weights of girls given in example 2 for which n was 15, x bar was 30.9, and construct a 95% confidence interval estimate of the man birth weight of the, it should be mean, mean birth weight of all girls by assuming that sigma is known to be 2.9 Hg. So you're actually given sigma is known. And that's really a key thing. You're given n is 15, you're given x bar is 30.9, and you're like, but Ms. Nensey, we just go ahead and deleted everything from our data. Yeah, that's okay. We're going to do this by hand anyway. So the first step is check requirements. Guess what? It's already checked. We checked this because it's the same example as before. So checked already. I don't have to recheck it. If you had to recheck it, you have to say it. You have to do, it says SRS. We have to draw the box plot and so on. It's the same example from 2. So if you look at 2, we already did it. The second step is to find your critical value. So we're not doing T of alpha over 2, we're doing Z of alpha over 2. And if you go back to the first section, you have the chart already. So what was the 95% confidence interval? That was the 1.96. Okay. If you don't remember how to get it, it was inverse norm of 0.0250 and 1. Okay, so that's how you find the 1.96. The third step was to find your margin of error. And again, I'm going to write out the formula. So the formula is Z of alpha over 2 times sigma over the square root of n. So I'm going to do 1.96 times, and sigma is 2.9 over your square root of n. And how many values are there? There are 15. Notice I haven't used 30.9 just yet. We will be using it, but not right now. And we're going to go ahead and solve it. So we're going to do, I'm going to quit this, 1.96 times 2.9 over the square root of 15. So I get 1.468. And what's my fourth and final step? Same thing, find your confidence interval. So how do you find it? It's your X bar plus or minus your E. Okay, so what's my X bar? Well, I gave it to you as 30.9, and you have 1.468. So we're gonna, you can't leave your answer like that. You actually have to calculate it. So we want your answer out in like a parentheses version. Okay, so I already did the math. We got 29.432 and 32.368. Okay, and what is your final step? Your final step is to write a sentence. Okay, which I'm not going to do, but you're gonna write your sentence. Okay, good practice, because I think you have on your homework, you have like 16 problems, and I think almost every single one of them, except like 2 of them, ask you to find a confidence interval, meaning you're gonna be writing a sentence for almost every question. All right, we're almost done. So I wanted to do an example again by calculator because it's very helpful. So it says use the same 15 births, so the same problem from example 2. So n is still 15. X bar is still 30.9. Notice it's the same number. We're still calculating 95% confidence, except now we have sigma to be 7.1. And you know, because it says sigma, it should now be 7.1. Again, same example, different numbers. I wanted to go ahead and use a calculator. So by calculator, you would do the same thing. You would have to check the requirements, but since it doesn't say to find your margin of error, you don't actually have to calculate that unless you're doing it by hand. But if sigma is known, you're going to be using, and I'm going to write it out. You're going to go again to stat tests, but instead of a T interval, we're going to be using Z interval. Okay, and again, you do have to label everything. Okay, so I'm going to go ahead and go to it. I'm going to go to stat tests, and it's going to be, I didn't write the letter, it's going to be 7. Okay, so it's going to be 7. And is this data or stats? This time it's actually going to be stats because we're not looking at lists anymore. Okay, so it's going to be stats. So what is your sigma? Well, if you wrote this out, it's 7.1. Guess what? I already did it. Your X bar is 2.625. Actually, that's not correct. Your X bar is 30.9. My N, how many people were I looking at? I was looking at 15. And my confidence interval was 0.95. So that's correct. And again, I do want to write all this out. So I do want to write what test I'm doing. And you guys see all these tests. You're actually going to be doing every single test in this class. Slow and steady, we do every single one of these. So we're going to do Z interval. I'm going to write sigma equals 7.1. X bar is 30.9. N is 15. Confidence level is 0.95. Like, I'm literally writing down what I typed up, even though some of it was already filled in. I'm going to hit calculate, and guess what? It gives me my confidence interval right away. So my confidence interval is 27.307, and 34.493. And it already gave me X bar and it gave me 15. So I'm done. This is literally all I have to do, and then I have to write sentence. Okay, the only thing I didn't do for this is you do have to check your requirements, but everything else is done for you. So again, this is by calculator. If you were doing it by calculator, you do have to write out what test you're doing. That's how I know the difference between Z interval and T interval. Okay, and that's essentially it. Now here's a little summary to help you guys out. So when do you do an appropriate test? So if you don't know sigma, okay, if you don't know sigma or sigma known and it's not greater or equal to 30, we use T. Okay, this is like a little summary of this entire section. If we know sigma, okay, we use Z. The third one is if it's not normal and n is less than, remember it's not greater than, we actually cannot solve and we just stop. Like you've done. Oh, I can't solve this. Okay. The last one is I wanted to actually add the section from 7.1 is if you have the population proportion P, and this is from 7.1. I'm just adding it in. If you know the population proportion P, we're going to say use normal distribution or normal or Z distribution. And that's essentially the entire chapter. Like this chart right here is like the best synopsis ever. Okay, let's go ahead and do one more example where you have to solve for n. Again, we're doing some algebra in here. So it says about how many people would we need to be surveyed if you wanted to use the margin of error in a study to be 3.2%. Use sigma equals 1.15 and Z equals 1.96. So I'm going to have you guys look at this. You're given E to be 0.032. You're given sigma to be 1.15. You're given Z to be 1.96. We don't know what n is. Okay, so we're going to go and write out a formula, and you're like, okay, margin of error formula. Which one of the three do I use? Well, since I gave you sigma, you should know, okay, so since I give you sigma, we're going to be using Z of alpha over 2 times sigma over the square root of n. Okay, again, there are three formulas. This is the one we're going to be using because I gave you sigma. Okay, so I'm going to go ahead and substitute some values in. So I know this is 0.032. I know Z is 1.96 because that's what it told me. Times, I know sigma is 1.15 over the square root of n. Oh, great. I'm going to do some algebra here. So here's a little cool trick, and I'm going to test it out first if it works. Okay, so if there is no denominator, there's two ways to do this, and there's actually multiple ways to do this. I was thinking of an easier way to do this than what I had before. Is these two right here, if there's no denominator, it's over 1. I'm going to multiply these two numbers together. Okay, and you're like, wait, didn't you say to round at the end? Yeah, but 2 decimals times 2 decimals, the worst is going to be 4 decimals. I'll just write it all out. Okay, or you could have divided both sides by 1.96, but I'm going to go ahead and multiply these out, which I did, and I get 0.032 equals 2.254 all over the square root of n. Okay, again, I want to solve for n. And then, so the next thing I'm going to do is I'm going to multiply both sides by the square root of n. I can't square root both sides just yet because you have to have the square root by itself to square it. So this goes away. And I'm going to divide both sides by 0.032. So essentially what I have is the square root of n, because this goes away, equals 2.254 over 0.032. Now that I have the square root by itself, I'm going to square both sides. And notice for this one, I do have to put a parenthesis because I want to square this whole thing. And I'm going to go ahead and use my calculator. So I'm going to do parentheses 2.254 divided by 0.032. Notice it is in parentheses. I'm going to go ahead and square the entire thing. And I get 4961.4. Now, if you leave it like this, you're actually going to get it wrong. Or you're not going to get full points. You're actually going to get half of your points. Well, if it was like a 5-point assignment, this would be, you would get 1 point off. Okay, because you remember n, you have to round to a whole person, and you're always going to round up. So even if this is 4, it's a person. So you want to actually overestimate. So the answer to this is 4962. Okay, so I'm going to write this again. Always round up. Okay, and that is the end of chapter 7. Thank you.